Hi, welcome to another 4AC learning video. In this video, we want to look at example 2.2d, which is found in your lecture notes. For the following pairs of voltages and currents, I would add sinusoidal waveform, indicate whether the element involved is a capacitor, inductor, or resistor, and determine the value of the capacitor, the inductor, or the resistor by just understanding the waveform itself. So how do we do that? Let's see. Well, before answering this question, we may want to do a quick revision of the meaning of each one of these. For example, if we know that the voltage and the current waveforms are in phase, that means when the voltage reaches the maximum, the current reaches the maximum as well. When the voltage reaches minimum, the current goes to minimum as well. Now this kind of waveform tells us that the circuit is resistive. That means it's predominantly resistors. Now if we found that the waveforms is such that the voltage waveform is actually leading the current waveform, that means current waveform is a bit behind, right? Voltage reach maximum where current still not so. This we will say the circuit is predominantly inductive. That means it has a stronger inductive reactance which cancel out any capacitive reactance, and also may have some resistive, right? And then finally we have when the current is ahead of the voltage waveform. This voltage and the current is ahead of it, like that. Now in this situation, we say our circuit is predominantly capacitive. Now there's only one special case when it's ahead by 90 degrees. Then we know, let's say for example, if the voltage is ahead by 90 degrees, we know that it's a pure inductive circuit. If it's ahead, if the current is ahead by the voltage by 90 degrees, then we know it's a capacitive circuit. So with this knowledge, we can then address the questions that was posted. Alright, so if we were to look at the first one and understand the waveform, you can notice that this time t, the voltage is plus 40, which means it is something like this, right? So this is the voltage. And what happened to the current? The current is minus, so current is here. So current is lagging the voltage by how much? By 90 degrees. Okay, so that's the first situation. Now second situation, the voltage is again ahead. I draw it here. In the second situation, the voltage is ahead by about 80 degrees and the current is behind by 10 degrees. So the current is here, right? 10 degrees. So again the difference is 90 degrees, but the voltage leads the current. I'm sorry, I've seen it wrongly. It is negative, so it should not be like that. Let me redraw this. It's the other way. the voltage is behind. Voltage means behind, means like that. It's behind by 80 degrees, so this is the voltage, but the current is ahead here by 10 degrees. Right? So that's current. So in this scenario, again, it is 90 degrees different. So we can say that this circuit is capacitive, whereas this is inductive. And finally, the last circuit, the last waveform, they are in phase because they all both have a lag of 103. 103 means at this point, at this point here, this point is 103 degrees. Right? The current similarly is the same thing, but the current may be in the same phase, but it may be at a lower magnitude or something like that. So this is voltage and this is current. So we say it is in phase, therefore it is resistive. So from this analysis of these three set of waveform, I can conclude that the first set is due to an inductor, the second is due to a capacitor, and finally the third is just a resistor. Okay. So that's the first part of this question. Now the second part of this question, all I can summarize here is, first part, I, the current, lags the voltage by 90 degrees. Okay. Lags by 90 degrees. And since it's lagged by 90 degrees, we can calculate XL. That means it's an inductor. XL is equals to omega L. Right, and XL can also be calculated from the expression here, which is 550 divided by 11, which means that L is equals to 550 divided by 11 multiplied by 377. So that gives me an inductance of 133.3 millihenry. Right from here. 5 over there. Okay. Similarly, for circuit group number 2 is the capacitor, because the current leads the voltage by 90 degrees. So this is an capacitive circuit. So the reactance XC can be calculated from V, which is 36, divided by current, which is 4, that's 9 ohms, which is equals to 1 over omega C. So from here, C is equals to C is equals to 1 over 747 omega 754 multiplied by 9. 754 multiplied by 9, which is equals to 147.36 microfarad. And finally, for inductive circuit, because these two are in phase, so V is in phase with current I. Therefore, R is equals to V 10.5 over 4, which is 2.625 ohm. Yeah. Okay. Hopefully, you learned something here. Thank you. Bye bye.